Good morning, viewers. Myself, Dr YDC, working as Associate Professor in the Mechanical Engineering Department, MIT Mysore. Today, I'll be teaching a topic called special type of welding. Okay. So here, before we get into special type of welding, we must know what actually the meaning of welding. So let us have the definition of welding. That is, welding is basically a joining process where you are going to join similar or dissimilar metals with the application of heat and with or without the application of pressure. That is what the concept of welding process. So we will be learning the special type of welding process. Here you have got different special type of welding process, that is resistance welding, friction welding, then explosive welding, thermite welding, then laser welding, then electron beam welding. Okay. So these are all the different special type of welding processes. So here in the resistance welding can be further classified into 4 types. That is, the first one is butt welding, second one is seam welding, third one is spot welding, and fourth one is projection welding. These are all the classification of resistance welding. Okay. So then what actually the concept behind the resistance welding, what is the working principle of resistance welding? So here whenever the intention of resistance welding is to make a particular joint. Okay. So how will I know the working principle behind that one is, so here the working principle is simple. If you pass a current to the metal to be joined, then that is going to offer some resistance to the flow of current. Okay. Then that leads to the generation of heat. That heat is more than sufficient to join these two metals or alloys. Okay. That is the concept of resistance welding. Once again I will repeat. So whenever you pass a heavy current into the metal to be joined, then that is going to offer resistance to the flow of current. So in turn that is going to produce heat. That heat is enough to fuse and the bringing into the fused state or plastic state, and you apply some appropriate pressure, then that is going to provide a particular joint. That is the concept of resistance welding. So that is the mathematical model for this resistance welding process is, so heat is proportional to I square RT, okay, where Q is heat, where I is current in amperes, where R is resistance in ohms, then T is time for flow of current in seconds. Okay. This is what the working principle behind resistance welding. Okay. And so I will repeat. So resistance welding is basically a special type of welding process where you are going to join two different metals or alloys. Whenever you pass a current to the metal to be joined, then that is going to offer resistance to the flow of current. In turn that leads to the generation of heat. That particular heat is more than enough to fuse the two metals to be joined, then ultimately that results in a particular joint. That is called resistance welding. So working principle is based on this mathematical equation, that is, heat is directly proportional to I square RT, where Q is heat generated, where I is the current in amperes, and R is the resistance in ohms, and T is the time for flow of current. Okay. That is what the working principle behind resistance welding. Okay. Then what would be the advantages of having resistance welding process? So here the first advantage is fast rate of welding. Okay. So the fast rate of welding in the sense that the productivity is obviously high. Okay. That is the concept of fast rate of welding. then though no filler materials are required as we have considered in the arc welding or in some other welding processes. Then both similar and dissimilar metals can be welded. That is the beauty of this resistance welding process. Then what are the disadvantages of resistance welding? So basically initial investment is high, then the equipment, it has got a lot of electrical equipment that demands a good amount of maintenance. Okay. Then higher thickness material cannot be welded with this resistance welding process. That is the disadvantages of resistance welding. Then what is the application of resistance, where actually it is being applied? Okay. The first one is joining of sheets, bars and tubes. This particular process is preferable. Then if you want to have a precise application orientation, then you can consider the aircraft industries, and in automobile industries this particular resistance welding process is considered. Okay. This is about the applications of resistance welding. Then let us take up the first classification, that is butt welding. Okay. So here this is a butt welding, is also called as upset welding. Upset welding. Here it has got a movable clamp. This is fixed clamp. These are all the metals to be joined. This is the power supply. This is the power supply. Okay. So here you have got two different workpieces. Okay. These are all the two different workpieces, that is fixed at a fixed clamp, and this is movable clamp. With the help of hand lever, you can bring this particular metal to be joined close together like this. Then switch on the current. Okay, switch on the current. Then that is going to flow. The current is going to flow through these two particular what you call the workpieces. Then this material is going to offer resistance for the current flow. Then the heat will be generated. Okay, with the application of pressure and heat, that would result in the weld. This is before welding process, this is after welding process. This is bulge. Okay. Then after the completion of this particular process using machining or grinding process, you can get the appropriate dimension of this weld. Okay. So this is what the concept of butt welding. The next concept is spot welding. So spot welding is basically a resistance welding where you are going to join similar or dissimilar metals. Here this particular spot welding is mainly used for sheet metal welding. Okay. So here both ferrous and non-ferrous metals can be welded with the help of this spot welding process, and the constraint is the thickness of the metals to be welded should not exceed 8 millimeters. Okay, that is the constraint of this particular process. Then the parameters like pressure should be in the range of 22 to 55 Newton per millimeter square. Okay, that is the pressure being applied to get the particular weld. Then the another parameter, that is low voltage of 30 to 40 volts are required. Then we need to send pass high current of 120 to 300 amperes. Then sheet get welded within 10 to 15 seconds. Okay, these are all the parameters one has to set for the particular setup so that we can have a good quality of weld. Once again I will repeat, the spot welding is basically a resistance welding where the sheet metal being welded with the help of this particular process. Both ferrous and non-ferrous metals can be welded within the constraints of 8 millimeters of thickness. Then pressure of 22 to 55 Newton per millimeters being applied. Then as low as a voltage of 30 to 40 volts. Then the current of 120 to 300 amperes. Then it takes 10 to 15 seconds to get a final particular process. Okay. Then working principle, this is the setup of the spot welding. Here this is movable electrode, this is fixed electrode, here these are all the sheets to be welded. Okay, so this is the spot welding cycle. Okay, so here, as I said earlier, this particular process is meant for welding sheet metals. So it has got two electrodes, one is fixed electrode and another one is movable electrode. Through this movable electrode, you are going to apply pressure with a range of 22 to 55 Newton per millimeter square. Okay, then once these two electrodes are come in contact with the workpiece to be welded, then you can switch on the machine, then that is capable of sending the appropriate voltage and current. Then application once you send the higher current, then this material is going to offer resistance for the current flow. Okay, then that particular process leads to the generation of heat. That heat is more than enough to fuse these two particular sheet metal, then finally that would result in a particular joint. That is the concept of spot welding. So these are all the spot welding cycle. Okay, so this particular trend shows how actually the working or the welding being done. Okay, so here the y axis shows the pressure and x axis shows the time. Okay, the initially the process starts with the application of pressure. So here this is the initial stage, from 0 to some pressure being applied, the pressure is increasing, and once it attains the particular stage, you are going to maintain the same pressure throughout the cycle. Then this is the welding time. Okay, this is the squeezing time. Then after the welding process, you need to maintain the same pressure. Then once the welding is achieved, then the pressure is being dropping down at particular point 3. Then this is the off time, where you can leave the weld to or expose the weld to the atmosphere, then that is going to absorb the heat from the that is going to leave the heat to the atmosphere. Then subsequently that is going to ready for the next cycle. Okay, these are all the dotted lines shows the next cycle spot welding process. Okay, that is the concept of spot welding. The next welding process is seam welding. So seam welding, it has got two copper wheels. The copper wheels are acting as a electrodes. Here this is copper electrodes that is rotating with some RPM. These are all the sheets to be or the metal to be welded, and this is the side view and this is the front sectional view of a particular process. Okay, so here again the concept is same. This current is passed through the copper electrodes and apply some appropriate pressure. Then that particular current that is going to, whenever that is come in contact with the workpiece, that is going to offer the resistance. Then due to that particular resistance to the current flow, the heat is generated. That particular heat is more than enough to fuse the particular work material. Then that leads to the generation of a particular weld. Okay, that is the concept of seam welding. That is the next concept is projection welding. This projection welding is similar to spot welding. This is similar to spot welding. Okay, so here it has got two arms, that is this is movable arm, this is fixed arm, and this is projection workpiece, and this is flat workpiece, and through this power supply is provided. This is the setup of the projection welding. Okay, so as I said earlier, this is very similar to spot welding. whenever a lot of projections come into picture and that is to be welded to a flat sheet, then you can prefer the projection welding. So, working principle is simple. So, here whenever this particular workpiece come in contact with a flat workpiece, then if we switch on the machine, then that is going to provide appropriate voltage and current, that whenever the current flow into the workpiece, then that is going to offer the resistance. Then in turn the heat is generated, then that particular heat is more than enough to fuse the materials to be welded, then ultimately that results in the perfect or the good quality of weld. That is the concept of projection welding.